Oblique asymptotes. When you are playing with rational functions and deciding whether or not you have asymptotes, when you're looking at horizontal or oblique asymptotes, you will notice that if the degree of the numerator is exactly one more than the degree of the denominator, then you have an oblique asymptote, right? You either have oblique or horizontal, but not both. So you look at the degree of the numerator denominator. To find the oblique asymptote, we are going to divide the numerator by the denominator and then disregard the remainder. Okay, the quotient is the equation of the oblique asymptote. Sometimes that's just easier to do in an example. So let's find the oblique asymptote here. Now, first, recognize that the degree of the numerator is 2, the degree of the denominator is 1. So since our numerator degree is exactly one more than the denominator, we have an oblique asymptote. So we are going to do long division. So if I have x squared plus 0x plus 1, right, that's my numerator, and we're going to divide by x minus 2. Now, I don't know the last time you did long division with polynomials, a little bit different. So we're going to take x squared divided by x. So think what that means. X squared divided by x. Well, that leaves me with just x, right? Because I have two x's in the top, so I down to just one. So I have x. Now, we're going to take that x and multiply it by what's on the outside. So x times x minus 2, which leaves me with x squared minus 2x. So that's the piece that comes down. Now, I subtract, and I'm subtracting the whole thing. So I'm going to have x squared minus x squared. Well, though, that's the whole point, is those go away. Then I have 0 minus a negative. Well, two negatives is a positive. So I have left 2x, and I'll bring down my plus 1. And then we do it again. So I have 2x divided by x. Well, 2x divided by x, my x's cancel out. I'm left with just 2. So that's plus 2. Again, I multiply, so 2 times x minus 2 gives me 2x minus 4. I subtract, 2x minus 2x goes away, 1 minus a negative gives me 5. So I have a remainder of 5. Now, if you recall from that previous piece, we're going to take the quotient of this, the remainder we don't care about, so just the x plus 2. So my oblique asymptote will have the equation of y equals x plus 2. So it's all about that long division. Now let's go ahead and look at the graph of that. So the oblique asymptote is going to give us, as you can see, it's the equation of a line. It's x plus 2. So that will give us a nice piece here. We do end up actually with a vertical asymptote at x equals 2. And that's why you can see those two blue graphs that kind of go in there. Let's do one more here. Now here, again, we're taking a function. We have x squared plus 3x plus 4 all over x minus 5. So when you think about it, we have degree 2 in the top, degree 1 in the bottom. Because the numerator degree is exactly one more than the denominator, we are going to have an oblique asymptote. Now, in the last one, we did long division to find our piece, which is generally how it's done. But we're going to do this one with synthetic division. See if it gets us the same or the correct answer. So remember, with synthetic division, we start with our coefficients and our constants. So I'm going to have 1, 3, 4. And then the number on the outside is based off of, well, we're dividing by x minus 5. So what makes that 0? Well, x equals 5 makes that 0. So 5 is what we are going to put on the outside for our synthetic division. And now, do you remember how to do synthetic division? Our 1 comes down. And if we are on the outside, we multiply. So I'm going to take 5 times 1, which is 5. And then on the inside, we add. So 3 plus 5 is 8. 5 times 8 is 40. 4 plus 40 is 44. Now, because we started with an x squared, we divided by x, that means our answer will drop down by 1. So the x squared becomes 1x. Then we have our constant. And last we have our remainder. So x plus 8, remainder 44. Well, as you know, we don't care about the remainder. We only care about the quotient. So our oblique asymptote for this case is y equals x plus 8. So you can either use long division or synthetic division. It'll work the same way.